You are listening to The Vocal Technologist. Spoken tech for your ears.
Okay, so if you're like us, your feeds, your inbox, everything, it's just this constant flood of tech news, right?
Absolutely, it's relentless.
You've got these huge infrastructure deals popping up one minute, then bam, a massive system failure the next.
And mixed in with all that, you get these biological breakthroughs that honestly sound like pure science fiction sometimes.
Yeah, it's a lot to keep track of, let alone process week to week.
It really is. We've been wading through all of this material, and the big job is always synthesis, isn't it? Connecting the dots. Linking these giant multi-billion-dollar tech ambitions right down to the nitty-gritty reality of how engineering actually works, or sometimes doesn't.
And then throwing in molecular science on top of it all.
Exactly. It's quite the mix.
So our mission here, as always, is to try and cut through some of that complexity for you.
Yeah, focus on what really matters.
Right. Focus on the shifts that are genuinely reshaping the landscape, give you the essential knowledge, hopefully pretty fast. We're going to connect those huge future-shaping plans with the immediate and sometimes, like you said, surprisingly fragile reality on the ground.
Okay, so where should we start? Maybe right at the top. The AI infrastructure arms race.
Good place.
Okay.
The sheer scale of the computing power grab happening right now.
It's unprecedented. The amount of money being thrown at computational capacity is just staggering.
Okay, let's unpack this a bit then. Sam Altman, he's been on what people are calling a deal-making blitz, yeah? Aiming to lock down, quote, seemingly endless computing power for OpenAI.
That's the narrative.
But here's the bit that gets me, the fascinating twist. OpenAI. They're not profitable, like not even close yet.
And that's what's so interesting about the strategy here. It wasn't just about getting servers. It seems like it was a deliberate move to tie the actual financial fates of the world's biggest chip makers and cloud providers directly to OpenAI's success. A startup, remember, that isn't making money.
And the market's reaction.
Investors, bizarrely maybe, seem to love it. The stock prices of the companies involved actually jumped.
So are we just throwing out basic business rules now? Is the potential upside really seen as that guarantee that the whole economy is sort of backing this one massive bet?
Well, the belief seems to be that the upside is almost existential. You have to be in the game. Look at Google and Anthropic.
Okay.
That cloud deal. We're talking tens of billions of dollars.
Tens of billions.
Wow. And it's a commitment to bring over a gigawatt of AI compute online by 2026. Using Google's own custom chips, their TPUs.
Gigawatt. You got to pause on that. For you listening, that's like power for a small city.
Pretty much. All dedicated just to training AI models. It really puts the scale of what they're trying to do into perspective.
It absolutely does. And that huge long-term bet, how does that square with the immediate costs? Because the burn rate must be painful.
Oh, it is. We know Anthropic, another big AI player, they spent something like $1.359 billion just on AWS.
In 2024.
1 year, one vendor.
Exactly. Which immediately tells you why spreading the load is crucial.
Diversification isn't just a nice to have, it's survival.
For sure. Putting those massive workloads across different clouds, it's not just about backup. It's about tweaking things constantly. You know? Finding the best price, the best performance, managing power constraints, basically playing the vendors off against each other just to keep the lights on affordably.
Right. It's high-stakes optimization day in, day out.
Just to keep operating.
Okay, so high stakes, massive investments, the future of tech kind of tangled up in these deals.
Yeah.
But you have to ask, right, what happens when that bedrock, that cloud foundation itself, what happens when it cracks?
Whoa.
Because we just saw that happen, didn't we? The whole Amazon cloud empire basically ground to a halt. It was pretty dramatic. A day-long AWS outage took down loads of major websites. And yeah, while some services came back fairly quick, the whole system wasn't really fully normal until, after 6 p.m. Eastern?
Yeah, well into the evening. And this is where it gets really interesting for me.
The post-mortem.
Exactly. The explanation of why this billion-dollar system failed. It's like a perfect lesson in how fragile these complex systems can be. It wasn't some huge cyber attack or anything.
Oh, not at all. The root cause. It was a single, tiny technical detail. A DNS race condition.
Okay, hold on. DNS race condition. For anyone listening who isn't deep in the weeds, can you break down what that means and why it caused such chaos?
Sure. So think of a race condition like this. You have two different automated processes, process A and process B, and they're both racing to finish a job that affects the same thing. But if their timing gets messed up, they can accidentally create a result that's impossible or just plain wrong. In this case, AWS has this automated system for managing DNS, which is like the internet's phone book, for one of its core databases, DynamoDB. There's one part, the DNS planner, that makes plans for changes, and another part, the enactor, that carries them out.
Got it. Planner and enactor.
Right. But the enactor started experiencing unusually high delays. It got bogged down. Meanwhile, the planner didn't know that. It just kept racing ahead, making new plans. Eventually, it made a plan that, when finally enacted, accidentally created an empty DNS record for a critical DynamoDB endpoint.
So, the phone book entry for this vital database suddenly pointed nowhere because one part of the system was too slow and the other was too fast.
That's basically it. One tiny timing hiccup in an automated background process, and boom, a central database service collapses, taking a huge chunk of the internet with it.
It's a stunning display of vulnerability, isn't it?
The implication is huge. You can pour billions into infrastructure, like we just talked about, but these critical systems still depend on these really complex automated chains. And a simple timing issue, a race condition, can bring it all crashing down.
And they had to shut that automation down globally, right?
Yeah.
Until they fix it.
Yeah. Completely disabled worldwide until they can build in better safeguards. It just hammers home that complexity. It's the enemy of reliability. Always has been.
Absolutely. Okay, so we've gone from these massive infrastructure collapses. Let's zoom in now to how the code itself gets built. In this environment, super high demand, need for speed. How are developers changing how they even think about building software?
Well, the conversation is definitely shifting. There's this growing idea, some call it front-end maximalism.
Front-end maximalism.
The basic concept is that maybe doing almost everything on the front end in the user's browser or device is actually underrated and is becoming more and more possible. It challenges that traditional split, front end does this, back end does that.
That sounds really appealing, especially when you throw in these new AI coding tools. We're hearing Claude Code, for instance, is unreasonably good at building MVPs, minimum viable products.
And that's the key, isn't it? The MVP stage. When you're just trying to see if an idea has legs, things like technical debt or perfect code quality, they're secondary.
Right. You just need to know if people actually want the thing.
Exactly. And AI tools can drastically speed up that validation loop. You test more ideas faster, figure out what works with real users, then you invest the time in proper engineering, refactoring, hardening, but only for the ideas that actually survive.
Okay, but hang on. If the AI is just churning out code faster, and maybe that code isn't super optimized or elegant, aren't we just sprinting towards a massive wall of technical debt later on? That feels like where the skepticism must come in.
Oh, absolutely. There's a very significant counter-argument out there. Some folks think this whole AI coding assistant market might be a house of cards.
House of cards, why?
Because, they argue, the entire market is betting on a crucial assumption that these AI models will just keep getting better and better at writing correct, high-quality code automatically.
And if that assumption turns out to be wrong, or just, slower than expected,
then the whole thing could fall apart. The argument is that the real long-term win isn't just generating code faster. It's solving the foundational architecture problem.
Ah, okay. So fundamentally improving how we structure software in the first place.
Exactly. Making software inherently simpler, more robust. Small improvements there could have way bigger payoffs in efficiency and stability than just automating the creation of today's complex, maybe messy structures.
It's that classic tension, isn't it? Short-term speed versus long-term health. Just amplified like crazy now.
For sure. And speaking of long-term health and managing this stuff, there's an interesting point here for engineering managers.
Yeah.
Yeah, the idea that managers should sometimes actually write code.
Really? That sounds counterintuitive. Don't they have other things to do?
Well, yes, but the thinking is, if you stop writing any production code, your mental model of how software gets built today, it starts to calcify. It gets stuck a few years in the past.
Ah, I see.
So chipping in maybe on simpler features or fixes, it keeps your knowledge fresh. It helps you stay connected to the team's actual day-to-day struggles and maintain, relevant context and empathy.
Keep your hands dirty, metaphorically speaking. I like that. Okay, let's make a clean pivot now. We've talked digital construction, digital collapse. Let's talk biological construction. Because the stuff happening at the atomic, the cellular level, it feels like it's moving just as fast as the AI race.
It really does. And this is, it feels like humanity's next huge undertaking. Genome writing.
Not just reading DNA anymore, but writing it.
Exactly. You've got big initiatives like HEP Write, SynHG, the Synthetic Human Genome Initiative. The goal is to develop the tech to actually write DNA sequences to order. The potential impact on medicine, agriculture, materials, it's just enormous.
And we're already seeing results, right? Real-world applications in restoring human functions. Tell us about the vision restoration work.
Yeah, this is fascinating. Researchers have managed to give some vision back to people who've lost their photoreceptors. Those are the light-detecting cells in the eye.
How?
They're using a prosthetic retinal implant. It gets signals wirelessly from special glasses the person wears, which have a camera.
Wow. And what's the vision like?
It's still early days. It's black and white, kind of blurry, and the field of view is small. But it is vision. The really critical part, though, is that the patients need months of intensive training.
Training. Why?
Because their brain has to learn how to interpret these completely new signals it's receiving from the implant. It's like learning a new operating system for seeing.
Okay, so the tech provides the input, the brain has to learn the software. Makes sense.
But on the gene therapy side, some of the successes are, frankly, much cleaner and more dramatic.
Yeah.
Take bubble boy disease, ADA-SCID. The success rate there is incredible. Around 95% of kids treated were effectively cured with a single one-time gene therapy.
How does that work?
They take the patient's own stem cells, modify them in the lab to correct the faulty gene, and then put them back. No donor needed, potentially a permanent fix. It's truly transformative.
And the other huge shift is just accessibility, right? For you, the
mean,
listener, DNA sequencing isn't some billion-dollar project anymore.
Not at all. The cost has just plummeted. The first human genome cost, what, $2.3 billion?
Something like that, yeah.
Now, you can buy an Oxford nanopore sequencer, a little handheld device, and sequence your own DNA at home for around $1,100, maybe less, and get results in under 48 hours.
That's amazing. And it gives you control, doesn't it? You're not just handing your data over to some big company that might get breached.
Exactly. It's a massive shift towards individual agency over your own genetic information, democratization.
Okay, so the pace everywhere is just relentless. Cloud, code, biology. But all this speed, all this automation, it comes at a cost, right? Let's talk about the human side of this for a minute.
Yeah, the human cost is real and significant. Look at the scale of automation Amazon has planned. It's documented. They aim to replace over 500,000 jobs with robots by 2033.
Yeah, 500,000.
Yeah. And their own analysis says it saves them about 30 cents per package delivered. When you have goals like that, the impact on blue-collar work is going to be profound and fast.
And it's not just blue-collar jobs, is it? At the other end, the white-collar end, especially in AI research.
Oh, yeah. The AI boom has absolutely brought back that intense 9986 culture, 9 a.m. to 9 p.m., 6 days a week.
We're hearing reports of top researchers, executives regularly pulling 80, even 100-hour weeks.
And it's fueled by a couple of things. One is just hyper competition, right?
Yeah.
The race to get the next big model out first. But the other is genuine curiosity. The tools are so powerful, people want to push them. It creates this kind of irresistible self-imposed pressure cooker.
So the analysis is pretty blunt then. AI is making us work more.
Seems to be the case right now. The capability is demanding the time, creating the pressure.
Okay, so everything's changing incredibly fast. Systems are fragile, deals are enormous, the pace is nuts biologically, computationally. If you're trying to navigate all this, what's the best approach? What should you be thinking about?
Well, there was some great advice floating around recently aimed at the young person worrying about AI. And the core message was really simple. Don't bother trying to predict the future.
Really, just give up on predicting.
Pretty much. Trying to guess exactly what the world looks like in 10 years. It's usually a waste of energy. Things change too fast, too unpredictably.
So what should you do instead?
Design your life. Design your career for fast adaptation under uncertainty. Focus on understanding what's happening right now. See the underlying patterns. Build skills that let you pivot quickly. If you do that, you'll likely have enough time to adapt when the big shifts come.
Adaptation over prediction. That makes a lot of sense.
Yeah. And it kind of ties into a final point about career choices, too. You know, the classic big company versus startup debate. A lot of the thinking now suggests that, well, both environments are often pretty dysfunctional, just in their own unique ways.
Okay, fair enough.
So the real takeaway might be you just need to figure out what kind of organizational dysfunction you prefer to deal with.
So the specific company type, big or small, is maybe less important than what? Your immediate team.
Exactly. Having a manager who genuinely supports you, being on a team that actually clicks and works well together, having projects that are interesting and let you learn and adapt. Those things consistently seem to matter way more than the logo on the building.
It's a great reminder, isn't it, that no matter how advanced the tech gets, it's all built and run by people within organizational structures. And those are fragile, too.
Definitely. And maybe to leave you with one final thought, tying back to the AI code generation and that AWS outage. We talked about how the easy path right now often feels like just building apps faster, assuming the underlying AI models will magically get better.
Right, relying on the foundation to fix itself.
Yeah. But if everyone takes the easy path and ignores the hard path, fixing the foundational architecture, making systems inherently simpler and more robust, then the whole ecosystem stays fragile and complex, like that DynamoDB situation showed us.
So the question for you listening is...
Exactly. In your own work, in your field,
Yeah.
where are you maybe tempted by the easy path of just building on top of shaky ground? And where is the real long-term value actually hidden? It's probably in tackling the hard path, fixing the foundation. That's where the durable, non-fragile value gets created.
That's a powerful place to leave it. Keep adapting, keep questioning, keep looking beneath the surface. That's what we try to help you do each week here on Vocal Technologists. Thanks for tuning in, and we'll talk soon.
Spoken Tech, for your ears.